Did you see that epic cinematic? Yeah, that wasn't just a happy accident. I planned that foggy masterpiece. Wanna know how to make your game scenes look like they belong in a blockbuster, but without spending a gazillion dollars? Stick around, because today we're unleashing the magic of the fog card. It's like a fog machine for your game, minus the loud noise and the weird smell. Let's jump right in. Okay, so first things first, I'm gonna create a new project, and this is gonna be the same process like I showed you before, but I'm here speed-running this whole thing for now because I believe you already know this stuff. And don't forget to add the starter content to the project. Next, I'm going to rearrange some folders according to my needs. And I have here downloaded this mountain pack from Sketchfab for free, and shout out to this developer Solar Architect for creating this amazing mountain pack. Alright, on to the meshes. I'm going to import this downloaded mesh. I'm going to save this and bring it into my level, scale it up so that it has the appropriate size. As for the textures, you'll find the textures in the .rar folder. Into the textures folder, I'm going to create a new folder called mountain and import all the textures from the mountain here. Alright, once that's done, I'm going to create a new folder called fog in the textures, and inside the mountain I'm going to create a material called m_mountain and bring in the mountain textures. This is just a simple material process where you need to plug in all the designated textures. Base color into base color, normal to normal, roughness into roughness, and ambient occlusion into ambient occlusion. Once you've done that and set the material to the mountain is ready. Okay, next we're going to add a cinematic sequence or a level sequencer. Create a new folder and create the sequencer into that folder called cinematic. I'm going to name my sequencer as ls_fog because this is actually a fog tutorial. Okay, now I'm going to get a good position for my fog card test and save. Okay, once that's ready, I'm going to add the starter content because we need one texture from the starter content, and that's called Perlin noise. So Unreal Engine's starter content has this amazing texture called Perlin noise. This helps in a lot of material creations. Okay, next I'm going to create a material and name it m_fog, and create an instance of that material and name it mi_fog. Next, I'm going to bring in a plane and position it accordingly. Scale it up, rotate, and position. Scale again if you need to. Now, once the position is set, alright, into the material graph, we're going to change a few things. First, the blend mode to translucent. Cast ray traced shadows off. And change the lighting mode to surface translucency volume. Alright, once that's done, save the material, and next we can proceed. Bring in a texture sample, and in the details panel, while selecting the texture sample, search for Perlin noise. This should be it. Alright, we're going to add a texture coordinate and a multiply node by holding M on the keyboard and left click on the mouse. Next, I'm going to add an append so that we can have control over X and Y direction separately. Next, I'm going to add a parameter and name it Perlin noise X. And duplicate it, rename it to Perlin noise Y so that we have X and Y coordinates controls. Also, I'm going to add them to a group named Perlin noise so that we have a clean and organized material instance. I'm going to add a default value of 0.25 for both X and Y. Next, from the multiply node, I'm going to add a panner. From the panner's speed, I'm going to add an append node again to have the separate controls for X and Y. Alright, next I'm going to add two parameters, name them Perlin Noise Speed X and Perlin Noise Speed Y respectively, and connect them accordingly. Let's set the default value to 0.000625. Next I'm going to rearrange them a little and add them to the same group. After that, I'm going to create a new folder onto the textures called Cloud Fog. Okay, next I'm going to bring in my handy and custom made textures and save them. But before going any further, I have a little announcement to make. So, we are selling these cloud textures for free in Gumroad, but you have to buy the 2K and 4K version of the textures. And also, the custom noises are free as well. With these textures and you can create a whole bunch of awesome scenes. Just give it a try and test it out. Alright, besides that, I'm going to bring in my handy custom made cloud textures and create a new folder inside the texture called noise and bring in my noise textures. Save them. Once they're saved, bring in a noise texture that you like and we're gonna proceed to the next steps. Alright, from the noise texture, bring in a lerp or linear interpolation. Move the cloud texture up so that it has an organized structure. Plug the cloud texture to A and the noise texture to B. And the Perlin noise to alpha. Okay, next bring in a depth fade node and a gamma depth fade node. Okay, before implementing these two nodes, let me show you how this works. For that, I'm going to get a 3 vector for color and a multiply node and connect the depth fade and the color into the multiply and hook in the result to base color. Okay, as you can see here, the depth fade node usually helps to detect the static meshes around, and detecting the static mesh, it creates a gradient that allows us to fade away some portion or some part of the shader. The darker the area, the more faded the texture will be, and this will help us to blend into the scene. As for the camera depth fade, this works in the same way but for the camera. As the depth fade detects the static meshes, the camera depth fade detects the user camera or any sort of camera. Alright, now that's done. We're gonna move on into creating the shader itself. Next, I'm going to create the parameters for my depth fade and camera depth fade accordingly and name them as they are and change the depth fade's name a bit. Next, I'm gonna bring in a multiply node and connect the depth fade to B and the cloud texture RGB to A. Let's rearrange this. And now, from the multiply of the depth fade, I'm gonna get another multiply and connect to the B, connect the camera depth fade to A. Let's set the default values of the parameters that we just created. The camera fade length will be 512, the camera fade offset will be 24, the fade opacity will be 1, and the depth fade distance will be 500. Okay, from here I'm going to bring in another multiply node and connect it to the A. Next, from the lerp, I'm going to search for a static switch parameter and name it enable wind ? I'm going to duplicate this and set the default value to true. Okay, as for the false, I'm going to just simply connect the RGB of the cloud texture that I just have. And for the other one, I'm going to hook the result to B of the latest multiply node and create two parameters. Name one opacity with wind and the other just opacity. The opacity with wind will be a bit lesser than the opacity. The default value of the opacity with wind is 0.5 and just opacity is 1. Connect them to true and false respectively. Okay, next let's make a little room and add a frontal node. I'm going to promote the first two nodes to a parameter so that we can change the values later on and just keep their name as it is. The default values for this will be 5 and 0.04 respectively. Next, I'm going to bring in another multiply node and connect the frontal to B and the other multiply to A, and connect all of them to opacity. Next, I'm going to create another variable for my specular and set the default value to 0. Okay, once that's done, I'm going to plug in the switch parameters result to base color. Let's rearrange this a little. Bring in another multiply node and create a reroute pin from the base color and connect it to A. Set another parameter node and call it emissive. Set the default value to 0.3 and connect it to the multiply B. Next, connect the result to the emissive color. Let's rearrange this a little. Okay, we're done. Let's save and check it out. First, in the shader viewport, you won't see any results because we have the camera depth fade on. On the viewport as well, we don't see any results. But let's open our material instance and tweak some values. The issue here is due to the frontal node's parameters. We need to change the values a little to get the results as we want. I'm going to change and test with the values of the exponential and base reflect fraction to get the ideal result I want. Also, I'm going to play with the other values as well and try to get the result. Change it, resize it, and just play with the values and you should see some pretty good results. Change the opacity and emissive color to get a better view. And that's a wrap. You're now officially a Fog Card Pro. Go forth and blanket your game worlds in glorious cinematic fog. Just don't overdo it or your players might think they need glasses. If this video helped you out, hit that like button, subscribe for more Unreal Engine magic, and let me know in the comments what you're fogging up next. Until next time, keep it misty and keep creating. See ya!